is on. Fine. Now have you all formed the groups? See, this is the sheet I will share with you. Okay, let me explain what is there in this particular sheet. We will have something. Okay, fine. Okay, is the screen visible to you? Is the screen visible? I hope screen is visible to you. Okay, now what you have to do? This is batch 1, S1 batch. Now here in this S1 batch for PBL, you have to form. There are 17 students in this particular batch, so you have to form 3 groups of 4 students. So this is one group. Then, so one group. This is first, second, and third group, and only one group in this batch will have 5 students. Okay. Likewise, S1, S2, S3. You all will fill your roll numbers here, roll numbers and names. Okay, names in the list. I will share this particular sheet on the Google Drive. So I want your names here and the roll numbers. Okay, and only the last group before batch, S4 batch, there are 20 students in this particular batch. So this particular batch will have 5 groups of 4 students each. Okay, so what I will do, I will only share this particular sheet. Okay, this particular table. What I will do, I will share only this particular table. Okay, so this will become like this. My God. Okay, so this is S1 batch. S1 batch. Okay, and this is S2 batch. And this is S3 and S4 batch. Okay, I'll share this batch, share this particular sheet. You all have to fill this sheet today itself. Okay, after the lecture, I think you all have decided, to form the group with your friends. Okay, and remember, you cannot take inter batch students, other than your batch. Only S1 batch students will have this group in S1 group. Likewise, okay.
हॅलो हॅलो सर
Yes,
सर
okay.
एस टू बॅच मध्ये एक प्रॉब्लेम आहे, एक मेंबर परमनंट अब्सेंट असतोय
कुठं?
एस टू बॅच.
आता मग बॅच कोणाचं लहान असेल की नाही 3, त्याच्यामध्ये त्याचं नाव
हा
घ्यायचं. तो आला तर ठीक आहे, नाही तर मग नंतर कन्सिडर करूया.
मग एक ग्रुप 3 मेंबरचा होतो, मग त्यासाठी काय करावं लागेल?
3 मेंबरचं होतं तर चालतंय. तो 3 मेंबरचा, खरं तो आला इन केस, तो त्या ग्रुपमध्ये 3 मेंबरच्या ग्रुपमध्ये त्याला आम्ही हे करणार, काय मिक्स करणार.
ओके सर, ओके, थँक्यू.
Okay, yes, fine.
ओके सर.
So I will share this sheet today itself on the Google Drive, and I will share the Google Drive link also on the WhatsApp group or on the Moodle. Okay, you just go through this, and please all of you fill your names today itself, because again we have to work on PBL. We have to select the PBL project titles, and you have to submit synopsis, and you have to keep on working. We will at least virtually will in this particular subject, we will develop a software, small software, small problems. We'll give solution to small problems. where this can be considered as PBL. PBL problem definitions we'll see it later, but at least we form the group so that I can in the next week maybe I will discuss with some problem example statements which can be considered as data structure PBL problem statements. Is that okay? You all have to form the group. I will share this sheet today itself on the Google Drive, and I will also share link with link on WhatsApp as well as on the Moodle. Yes, any questions? Okay, fine. Now, what we were discussing yesterday? We were discussing unit 4, no? Unit 4 searching. So there are mainly two techniques in searching. Okay, one is linear search, second is binary search. Okay, linear search is what? Linear search is searching element each element one by one linearly, which is called linear search. Okay, so you'll see you'll get and it's very easy. Okay, both linear search and binary search are very easy. Linear search is also called as brute force search or sequential search, whereas binary search uses a technique called divide and conquer. So what we divide here? We divide the input size. And what is the assumption in binary search? The assumption is the data or input value input which we want to search in binary search is in some order, either in some sorted order actually, either in ascending order or descending order. So according to that, we can see whether whenever we want to search a particular element, we will take a middle of the total elements and we'll see whether the searching element is in the first half or second half. Then we'll only consider that either first half we'll search in the first half or we will search in second half. We'll keep on doing this. So by doing this, what will happen? The number of search comparisons, okay, that will be very much reduced. Suppose I want to search linearly in 1000 elements, maybe in worst case is 1000. If my element is present at the 1000 position, then I'll keep on searching from the first element, second element. I'll keep on doing this. And if unfortunately my number is at the last, what will happen? At a 1000th element, I will find a element which is matching. I will print as saying a message, the number found at 1000 position. If at all number is not there, what will happen? If number is not there, still I am searching 1000 elements, and after searching all 1000 elements, I will print a message saying number not found in the list. So this takes the worst case scenario in linear search is what? The number of elements. If number of elements are n, then it takes n comparisons. So that's why what is the complexity here? The time complexity is O of n. What is O of n? If n is 5, it is 5. If n is 50, the comparison will be 50. So that is called the complexity of linear search is O of n. It increases linearly. That is, it grows linearly. If number of elements increase in sequential search, the time complexity will also increase sequentially. What about in binary search? As binary search takes a very less time compared to linear search. How it is done? See, if we will do half part. If my element total size is 1000, first I will check. I will take a middle point which is 500. Either I will compare in first half 500 or second 500. Then I will divide this into again one more half. So again I will check whether I have to compare in first half 1 to 250 or 250 to 500. So I'll keep on doing this. So what is the time complexity here? If you see the time complexity at the end, it will be not more than O of log n or O of log 2n. Okay, we'll see this complexity later. But remember, the time complexity of binary search is very less compared to linear search. Linear search is O of n, whereas binary search it is O of log n. Okay, we will calculate that later. Let me first finish both the programs. So what is searching? Yesterday we have seen this in detail. So searching arrays, linear search, we can use for small arrays or unsorted arrays. If data is unsorted, I cannot use binary search. Remember it. So if data is unsorted, I don't have any other option. I have to search linearly, one by one. Okay, we have to say, take an example of yesterday example of housing colony where if there are 1,000 houses, okay, 1,000 residential houses are available. If the numbers are random, then I do not have any option. Each I have to visit each house and I have to compare the number, isn't it? If there is some some ordering is done of the all residential houses, then what will happen? I can check where it starts, and so that I can skip some some residential residences, and I can jump to next number and check whether the number is in the particular array, particular lane or particular line. So this is like in a binary search. Binary search can be applicable only for sorted arrays, and when we want to compare, when we want to search something like take an example, Aadhaar card. How many entries are there in Aadhaar card? If you see the Aadhaar server, Aadhaar database, around 130, 100, 110 crore to 130 crore. So everyone is having Aadhaar card in India. So it's almost Aadhaar database is having 100 and if you take approximately 120 crore records, and every record will have what your 12 or 13 digit Aadhaar number, your name, your thumb impression, your address, your phone number. So much data is there, and when we search elements like 130 crore records, if how you are going to search it? It's not possible, no? If it is unsorted, what will happen? It will take a lot of time. And remember, these are called social security numbers, Aadhaar number. Uh, at a given particular point, there are hundreds of people are accessing this Aadhaar card number. If suppose 1,000 people are accessing this Aadhaar card number, what will happen? You have to read this whole database and get this data. It will take a lot of time if it is unsorted. So there are many applications, not many applications, we can say in every application we need to order data in some order. Suppose if it is a telephone directory, what you will do? It's not integer. If there are numbers, I can either sort in ascending order or descending order. If it is a string or character or text, what I have to do? I have to sort this data, this input in dictionary order, like first ABC, like A to Z alphabetically. We have to sort all data. So linear search is mainly used in small arrays and unsorted arrays, whereas binary search is used in large arrays, and the complexity of binary search is very less compared to linear search. So, but what is the condition for binary search? Binary search, the assumption in binary search is the data is in some sorted order, either in ascending order or descending order. So what is linear search? Start at first element of array, compare value to the key for which you are searching, continue with the next element of the array until you find a match or reach the last element in the array. Note, on an average, you will have to compare the search key with half of the elements in the array. So average time complexity or average comparisons are how much? If I have 100 elements, on average the comparisons we have to do is 50. Maybe in first case I have to compare 4, but in the next case I have to compare maybe 90 elements. So this is on average we have to, what is that we have to compare? The middle of that. If 100 elements, then on average 50 comparisons are needed to search an element. That is average case. What is the best case? The best case is in linear search, when I start comparing, what is comparing random values in a list. If I get the first the comparison, if I get success, that is my searching element and the first element are both are same, then within one search I will get the result, that element found. This is what, this is best case. Average case is if I get a compare after comparing say around 45 to 50 comparisons, if I get my element found, then that is approximately average case. If my element is not in the list, what will happen? I would have to, if in 100 elements in linear search, I have to compare all 100 elements, and at last, if I don't get element which I want to search in the list, so element is not found. But how many comparisons I have done? 100 comparisons. So this is the worst case. Best case is always the first case, first comparison. Average case is the middle in this average, or we have to how we are going to find the average. I will run my program 10 times, and I will see in how many random values, how many in 10 searches, what is the time complexity I will get, and if I add all the time complexities and divide by 10, so that is the average case. Worst case is if I found my element at the end in 100 comparisons, if 100th element is the one which I am finding it, then that is the worst case. And if at all, if I don't find my element in the list, still I have to compare 100 elements. Again, that is worst case. So linear search code, suppose we have seen this, no? We'll skip this one. We'll go to binary search. Now how this binary search algorithm works then? So binary search may only be used on sorted array, eliminates one half of the elements after each comparison, locate the middle of the array, locate the middle of the array, compare the value at that location with the search key. If they are equal, then search is done. Otherwise, decide which half of the array contains the search key. Repeat the search on that half of the array and ignore the other half. The search continues until the key is matched or no elements remain to be searched. Suppose take this example. So how many numbers are there in this? You can see that array is started with 0. Last number is 12. That means I have 13 elements here. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are some random numbers. They are not sequential, but they are in sorted order. You can see that these are in ascending order. 1, 5, 15, 15, then 19 is greater than 15, 25 is greater than 19, and all. Suppose in this list I want to search a element number which is 19. So search key is 19. So what is my algorithm I have to do? I have to check the first element and the last element. So first is 0 index, last is 12. What I will do, I will find the middle point. How you are going to find the middle point? I will take this as the beginning, this as end. So beginning is 0 and end is 12. So begin plus end, which is 0 plus 12 divided by 2. So 12 by 2 is 6. So this is 6, which is middle. Middle of the array is 6. So I will compare with my key whether 19 is equal to 29. No, it is not equal. Then what I will do? If it is less than or greater than, this is less than this middle point, what I have to do? I have to exclude or ignore the second half and I have to compare in the first half. So I will keep begin as it is and I will change end. End was earlier at 12. Now I will make end equal to mid minus 1. Now middle point is 6. So this is not comparable. So I will make my end equal to mid minus 1. This will become 5. So beginning will be 0 and mid will be 5. Okay. Now search key 19. Middle of the array is 6. I'll compare a of 6, which is 29, with 19. 19 is smaller than 29. So the next search will use the lower half of the array, which is 0 to 5. Why 5? 0 is still beginning. End was 12. Now I'll make end equal to, this was mid 6. I'll make end equal to mid minus 1. So it becomes 5. So now begin will be 0, end will be 5. So in between 0 to 5, I have to compare. So what I will do? So beginning is 0, end is 5. Now what is the mid here now? Mid equal to always 0 plus end, mid equal to begin plus end divided by 2. That becomes 0 plus 5, which is 5. Now 5 divided by 2 is how much? It is integer division. So 5 divided by 2 will become 2. So now a of 2, 2 will be mid. Now, so what is the search key? 19. Now this is mid, which is 2. Okay. Now use this as the middle of the array. You will compare the search key 19 with a of 2, which is 15. Now is key less than mid or greater than mid? It is greater than mid. So what I will do? End was here. Beginning was at 0. Now as we have to compare second half, I will skip the first half and I will make beginning equal to mid plus 1. Now beginning was 0. We will make it to mid plus 1, which will become 3. Okay, which will become 3. Now beginning is 3 and end is 5. Okay, beginning is 3, end is 5. Now what is mid here? 3 plus 5 divided by 2. So 3 plus 5 is 8. 8 divided by 2 will become 4. Now a of 2 we have to compare. A of 3 plus 5, 8 divided by 2 will become 4. This is the middle. We have to compare A of 4, which is 25, with 19. But 19 is less than 25. So what we have to do now? We have to take n equal to, so we have to compare in the first half. Now it was the begin, it was the end here. So as number is less than mid, I will make n equal to mid minus 1. Now beginning was here, end will also come here. Okay, so beginning was here, end will also come here. So we have to compare, suppose this is 3. Now index is 3. Both begin and end are comparing here. So 3 plus 3 is how much? 6. 6 divided by 2 equal to what? 6 divided by 2 equal to 3. Now compare A of 3. A of 3 is 19. And the comparing number is 19. So we found the number. We found the number. How many comparisons we used? 1, 2, 3, 4. In only 4 comparisons, we could find the number. Isn't it? Now suppose that was for successive success element. What if my number is this is the again same list, but I'm not. I want to find 18, 18 which is not in the list. Okay. Now what I have to do? Again, I have to find the middle point, which is 29. First half. You compare the first half. Now again find the middle point, which is 15. Okay. Now 15 mid is less than 18. That is my number. Searching number is greater than midpoint. So I have to compare the second half. So that becomes beginning equal to 3 and mid equal to 5. Now you will find the mid of this. Mid of this is 25. Is 25 is greater than or less than 28? So my searching key 18 is less than 25. So I have to compare in the first half. Now what will happen? We'll compare in this. So is the number same here? Number are not same. Or what will happen then? If number is not same, what is the condition here? If this key is less than mid or greater than mid. If less than mid, we will compare in the earlier. Now here it is less. So what I have to do? I have to make end equal to mid minus 1. Now beginning was here, end will go back here. Mid minus 1 becomes 2. So end is in reverse order. End is 2 and beginning is 3. That is the condition. If beginning is less than or equal to end, we will continue. Once beginning will cross end, that time we will stop. So we don't have to compare anymore. Elements are over. We have to come out and check whether number is available. If number is available, we will print it. Otherwise, we say number is not found. So searching searching an array of 1024 elements will take at most 10 passes to find a match or determine that the element does not exist in the array. See this, 1024 elements, you divide by 2, we have to compare only in 512, then 2, 5, 6, 128, 64, 32, 16, 8, 4, 2, 1. So what is this? This is log 2, log of 2 n, where we have to compare only this much values. An array of 1 billion elements takes a maximum of 30 comparisons. See this, 1 billion is how much? 100 crores. No, it is. So 100 crore elements, if numbers are present, only in 30 comparisons with binary search, we can find an element, whether it is a successful search or unsuccessful search. If number is present, within 30 comparisons, we will get it. If number is not there, after 30 comparisons, we can assume that number is not in the list. Okay. The bigger the array, the better a binary search is as compared to linear search. Whereas in 100 crore element, worst case is what? Worst case is 100 crore search, 100 crore comparisons. Best case is if the number is available, say maybe in 1, 2, 3 first places, we will find it in those places. And average case is your average, that is 100 crore divided by 2, which is 50 crore. Okay. Any questions? Any questions? If you have any questions, you can ask. We'll write the program for this. Now I can see there are some students who will join and in between they will leave the meeting. I don't know why, but remember all your log will be there with us. Okay, what time you log in, exact minute and second, what time you log out, how much minute, how much time you are spending with us on online lecture, all that will be there with us. Maybe I will show you yesterday's log. Okay, I'll show you yesterday's log where you can see that all log. You want to see log? Okay, let me show you log. Okay, let me show you log so students understand what we get here. Okay, I think you all are now screen is visible to you, isn't it? Is screen visible to you? Yes. Don't say no. Screen is visible to you. Okay. 29, 29 to 29. Maybe you will see yesterday's report, display report. Okay. So what is that? DS lecture detail. 77 attended. And for how long they are attended, what time, the starting time, duration, end time, everything will be there with us. Print. Okay, this is only summary. Maybe we'll have to check all the arrays. Okay. See this participant, their number and name and how much for how long they are present. 63 minutes, 62 minutes. I'll print a friendly format, export a format. Okay, I'll export it. So you'll get the detailed list also. Save. Okay. So this is email. Okay, we don't need email. Just remove this, hide it here. We'll hide it, hide. Date, yesterday's date, invited. Okay, no. Invited, registered. No, we'll remove these things. Delete. Now this is start time, end time, and how long you attended. Now you can see that I can just, if I can sort this. Okay, maybe company, all these things we don't need this. We'll just remove this one, delete. Okay, so participant here, if I can sort, I can show you who have attended for how long. Okay, maybe I will sort on duration. So we'll sort this one, sort, custom sort on duration. Now you can see this. These are students who have attended only 1 minute, logged in and log out. So we'll make it red, not red. We'll make it we'll fill them with red. 1 minute. So this is okay. These are students who have, okay, 10 minutes. So this is not sorted. No, it is sorted. It's sorted, but with numbers, as these are strings. These are strings, 1 minute and all. Okay, there are some in between here. We have 8 minutes and 9 minutes also. 861. So we have numbers. See this. Now these people are attending only hardly 20 minutes, 30 minutes max. Are you getting it? So do not leave lecture. Later, you will have all the records. If they ask for, if you do for every lecture, like if you are just logging in and logging out, then that is no use. Your attendance will be considered seriously later. If you have anything, if you have any problems attending lectures, you can always talk to your class teacher or subject teacher. but do not miss lecture or just log in and log out, because we will have all your records. Okay. Is linear search is clear? Yesterday we have done linear search. This is binary search. This was linear search program. I just copied it, this one, made some changes. Okay. What changes we made? So the first line was program to implement binary search. Okay, I did some changes here, only the title. Then enter number of elements. Enter number of elements in the list. Number of elements in the list. So I read number n. Then I will read n numbers. Enter percentage d. That is n. If I read n number, if my total size is n, I will tell user enter n elements of a list. Now I should warn user, if a user can enter any elements here. Okay, I will ask question. I will see whether students are attentive, whether they are really concentrating on our lectures. Maybe roll number, we'll start with roll number 11. Yes, roll number 11. Shreya, can you hear me?
Yes.
Okay. Now you can see that in here, I'll say enter number of elements, and I'll say number of elements are 10. Okay. They enter 10 elements of the list. So how I should enter numbers here? Can I enter any random number? Can I enter any random
Yes,
number here?
sir.
Yes. Like what? Like
Yes.
5, 1, 2, 10, anything? Is it okay? I can
Yes,
search
yes.
elements? Yes.
Yes.
Okay. We'll get next answer. Next, we'll skip Harnish. We'll come back Harnish later. We'll go to Suraj Patil. Suraj, roll number 13. Are you there? Suraj? C13, Suraj. Suraj Patil. Can you hear me?
Hello.
Suraj. Suraj? Okay, this is binary search. Suppose now my first line is program to implement this thing and enter number of elements. Suppose I want to run for 10 elements. Okay, n is 10. Then I will enter 10 input numbers. Okay, can I enter 10 input numbers randomly, any number?
Sir, repeat once again.
The input search in this particular searching of 10 elements, can I enter those 10 numbers randomly, any number? Input?
No, I think no.
No? What I should do then? No, you tell me 10 numbers. I will enter. Which numbers you want to enter? How you are going to enter 10 numbers, 10 input numbers?
Sequential.
Sequential, 1, 2, 3.
Sir, your question is not getting.
This is a binary search program. Okay. Suppose I'll run this one. Okay, run, I'll show you. Is the screen visible to you now?
Yes.
Okay, let me run this. It's running. Okay. I'll say, for example, I'll take only 4 elements here. No, I'll not enter. So can I enter 1, 2, 50, 30? Will it work?
No.
Why? Why not?
I think it is not sequentials or
Why
ascending order.
Why you want ascending order? Okay, ascending or descending order. So what is input? What is the assumption here? What you have to assume in binary search? The input are in some order. So in our case, we are considering as ascending order. We can also consider it as descending. Okay. So as per ascending and descending, you can change your logic. Okay. Now, why it is so? Because binary search, assumes your input is in some order, sorted order. Otherwise, binary search will not work. Okay. So this is the fundamental main difference between linear search and sequential and binary search. Linear search can work on any number, whether it is a searching, whether it is a sorted input or unsorted input, it will work. Linear search will work because we are comparing number each by each, one by one. We are comparing all the numbers in the list. Whereas in binary search, we will assume that the input list is in sorted order. So we'll compare number. First, we'll check the middle point. If the number is in first half or second half, only then we'll compare in that particular half, and we'll skip the other half. So that's why this is a mandatory that the input which is we give to binary search is in some sorted order, and I'm considering this in ascending order. I'll run this program, run it again. Maybe I will give say 5 numbers, then I'll say 50, 40, 30, 20 and 10. So this is descending order. I'll say 30. 30 is found position. As 30 is midpoint, I could find it. I'll use something else. Maybe 5 again, and 50, 40, 30, 20 and 10. 20. 20 not found in the list. 20 is there, no, in the list. As I'm considering it as what? Considering in ascending order. If a descending order, I have to just change only this one. Whether number is greater than mid or something. Only you have to change this logic. Run the program. Okay, I will enter some numbers. So what numbers we will enter? We'll see that the same input which is there in the PPT. In the presentation we have used, something. What was here number? This is the one which we have used. So we'll use this one. So how many numbers these are? These are 13 numbers. I'll say 13. What are inputs? 1, 5, 15, 19, 25, 27, 29, 31, 33, 45, 55, 88, 100. So what number I want to search? I want to search 19. So 19, enter. So it will say 19 found at fourth position. 1, 2, 3, 4. If you consider this 1. If you don't want, you want to consider this 0, then you can do that in the program. I have taken mid plus 1. Only mid you can take. Is it okay? This is working for search. If it is unsuccessful search, we have one more, no, here, unsuccessful search, this one. Same input, I want to compare it 18. Okay, we'll run this for this one. Run. Okay, what is the input again? 13 numbers. First is 1, 5, 15, 19, 25, 27, 29, 31, 33, 45, 55, 88 and 100. I want to search 18. Is 18 available? It says 18 not found in the list. Now why I'm printing beginning and end? I just wanted to see whether beginning will cross end. When we cross beginning, when beginning big is beginning crosses end, that means we have to stop. We have compared all the elements, so we'll come out. Okay, so this is your binary search program. Binary search using arrays. Okay, so how the program is written? First, the program to implement binary search, enter number of elements in the list, enter percentage number of elements, what you will read the numbers, then the number you want to search, that number you have to read. So enter a number to search, that I'm reading in number. Okay, then we have to make a beginning equal to 0, end equal to how much? N minus 1, because it's a array of array with index 0. So end is N minus 1. Now we'll find mid equal to what? Beginning plus end divided by 2. I'll find the mid. Then I'll compare while is beginning less than equal to end. If beginning will cross end, that time this is false. Beginning is not less than or not equal to end. In that case, I will come out. Or what is the other case? And if beginning is less than equal to end, and a of mid, the number which you are comparing, that is not equal to number, that is not equal to number, then only we'll compare, otherwise we will exit. If in the first point a of mid equal to number, this is false, I'll just come out and just check and print the message. Okay, so while beginning less than equal to end and a of mid not equal to number, then I'll check whether number is less than a of mid. If number is less than mid, I have to compare in first half. In that case, beginning is 0, end will become end will become mid minus 1. If number is not less than a of mid, in that case what it will become? It is more than mid or equal to mid. That in that case I'll make beginning equal to mid plus 1. Okay, and then what I will do, I'll find the new mid equal to beginning plus n divided by 2. I'll keep on checking this one. So when you will break the loop, we'll break the while loop in two cases. Either first one, if beginning crosses end will come out, that means we have compared all the elements in the list. Or what is the second case? If a of mid, my number which I'm comparing, if that is equal, in that case I will come out. So you find if beginning is less than or equal to end, that means we have ended our loop by this condition. That means we have found. In that case, I will make flag equal to 1. If beginning is less than or equal to end after comparison, that means I have found null number in the list. So I will make flag equal to 1. Else what I will do? Else I will say, else I just want to, else I have to skip this. But what I am doing, I just wanted to see whether what is beginning and end. So that's why the messages are beginning will cross end here. This is just to confirm. Okay, this is just to confirm that beginning is, that is BG, beginning process end and goes forward, goes beyond end. That means we have compared all the elements. You don't need this one actually. You don't need this one. Okay. Why if flag equal to 0? Initially there is flag equal to 0 means we are not found. So when it will become found? Whenever beginning is less than or equal to n, that means we are found. Only then I will make it flag equal to 1. So if flag equal to 0, what I will print message? I will print a message saying number percentage is this number not found in the list. Otherwise what I will do, I'll say number found at percentage position. What position it is? Mid plus 1. Or I can take, if you are if you are considering it as index to 0, I'll make it as just mid, not mid plus 1. Is that okay? Have you understood? Have you understood what is searching? There are many applications of searching. Searching is searching is part and parcel of every algorithm. If you see your cell phone, your file names, they are in order, ascending order, A to Z, because when data is in some particular order, it is very easy to search and find. Okay, your phone directory, it is with ABCD and all. So what is that? It is searching. It is sorted order. So searching, sorting are part and parcel of every algorithm. In computer, searching and sorting is very much necessary. All data should be in some order. Any questions? Any questions? No? Participants? Have you understood everything? We have type of where we search every element one by one, which is also called as brute force search. Okay, and second is binary search. Okay, maybe we will see of complexity, time complexity of binary search. No, yes, complexity is somewhere. Where is that time complexity? Time complexity. Okay, time complexity. So what website I told you to see the time complexity? What is the website name? Do you remember? It's called cheatsheet.com, no? Where it's called bigo.com. Okay. Is the screen visible to you? Okay. So what is O of n here? If my input is n and I need n comparisons, as and when n increases, comparisons will also increase. That is called O of n, or we call it linear complexity. Okay, linear complexity. What is O of log n? Now in our binary search, we have seen, no, for 1024 element, hardly we need maximum 10 comparisons. For 100 crore inputs, we will need worst case only 30 comparisons. In 30 comparisons, either the element will be found, or we will end up with saying number not found. So binary search will have time complexity of how much? This is sorting. Where is searching? Sorting is our next lecture. We will find see, these are comparisons, complexities of this. Binary is O of log n. Okay. Binary time complexity is O of log 2n. O of log 2n. Why O of log 2n? Because we are dividing our input by half. Either we will compare the first half or second half. So we'll keep on doing this. Do you have any questions? Do you have any questions? No? So we'll just see the syllabus. We have covered searching. Maybe we'll start with sorting. What is sorting? You all know? You all know, I think, what is sorting. Sorting is in some order, either in ascending order or descending order. That is either increasing order if numbers are there, or decreasing order. If there are alphabets, then alphabetical order. That is A to Z. The numbers, alphabet, the natural way of alphabet what we read, A, B, C, D. So either it will become A to Z or Z to A. So searching. So searching, we have finished. What is searching? Types of sequential search and binary search. Maybe we'll tomorrow we'll start with the sorting techniques. So we'll see bubble sort, selection sort, insertion sort, merge, quick, radix sort, and heap sort. So this will take some time because there are many sorting algorithms. Shall we end here, or we'll start with sorting? We'll shall we continue for sorting? It will take 10-20 minutes more. Maybe till 140 we'll continue, or we will start sorting tomorrow. If you don't give a response, any answer, I will assume it as okay, and I will continue this lecture till 140. Tomorrow, Prathamesh, CLR tomorrow. Okay. Okay, fine then. Then I will ask some questions. You should answer, or you will ask me questions. What you will do? Have you understood today's concepts? If it is yes, okay, okay, fine. Okay, we will till still we have 5-6 minutes more left, but we will end it here. We will end it here today. Tomorrow we will start with sorting algorithms. Okay, and we will try to cover at least 2 to 3 sortings in a day. Okay. Okay, we will end it here. I'll stop sharing. End the lecture.